Here is the short overview of Unit 6, Electricity, Power Production, and Climate Science. Again, a peek of the patterns that we're seeing in this unit. And then over here, you can see there's a number of performance expectations. So I'll actually zoom in a little bit. So we have performance expectations from physical science, engineering, technology, and society, earth, and space science. So many, such an important, impactful unit. All right, here we are at the website. And if we scroll down, I'll give the 30-second overview. It's really themed around students being on the Energy Plan Commission and needing to make a 50-year energy plan. So that results in our essential question being, how does STEM inform our future? I'm going to actually go right into and take each task one at a time. So first thing we do is Voices the World. And this is actually very first, so even before the introduction of the portfolio. So this is excerpts from interviews from people all around the world that are impacted by power production and climate change. Then they get introduced to the actual engineering portfolio that has real excerpts from the Oregon Department of Energy Biennium Plan 2022 is coming up, but it does actually reference a lot of the 2020 report. And then, of course, they get the problem statement, the constraints, and the criteria, which are mentioned numerously in the performance expectations. Just want to point out right away, like our system analysis, this is the first paragraph of their 5-paragraph essay, or you may just use the graphic organizers, but this really locks it in. So the problem statement, their constraints, the criteria, what is their highest priority and why. All right, good stuff. Then that portfolio needs to explain the background. How do electric power plants work? And of course, that allows us to get into the physics of motors and generators. I'm going to show just one quick video. We talked about it many times, electric guitar. So here's a video. It starts off acoustic in the first 2 seconds, and then we turn on the amp. So here we go. Oh, you don't. It's supposed to be. All right, so there is that $3 electric guitar. It is awesome. Of course, they make speakers for the motors. It is really awesome. But here is a peek at looking at what they do with it. So this is the generators, and they're playing with the FET. But again, tracking energy flow, cross-cutting concept energy, and then also use the tools of science to learn science. And then they use the big ideas of science to explain phenomena. And here's just a peek at that speaker, and you can see they're doing the same thing. All right, now, as cool as it would be to power the world by electric guitars, they just don't make enough electricity. So we got to talk engineering. How do we build structures that are big enough to produce and meet our energy needs? All right, so what is possibly unique? There's a lot of great stuff in this engineering project. This is awesome, but some student, we jigsaw it just like everything else. Some students might look at angles, some might look at size of blade, number of blades. So they're going to talk science. How does the number of blades affect the power output? Then they go back to their home group after they've gotten all 4 graphs, and they got to make engineering decisions, data-informed engineering decisions in light of the performance, cost, and trade-offs. Then it's on to a small engineering slice with solar power, because wind power and solar power are the 2 fastest growing power production means in the United States and worldwide. It starts off with a great phenomena. Why are solar panels installed differently in the Galapagos, Oregon, and Alaska? High interest, students figure it out, and it's fun to play with the solar panels and collect data that results in a new pattern. It's awesome. Then to complete our project, we've looked at the background physics of how they work, large scale power production. I skipped it in the short video, but you can see it in the longer video. They've already done some background research on the environmental impact and the economic impact, but now we got to figure out the climate impact of these different power production means, which is what justifies in our storyline diving deep into all those Earth and space science targets that we have. All right, so in the evidence statements, there's 10 factors called out, and we, with Sankey diagrams and a great station-like kind of activity, get through all 10. Another great several days. And of course, there's some hard-hitting climate change data woven in through there as well. Okay, with all that, we got all the pieces. It's time to make the energy plan and do computational thinking in a completely different way. So here is the 50-year energy plan. The green is where they're inputting. So it's really using the human brain and a spreadsheet to auto calculate things so that you can rapidly try out, rapid prototyping of a solution and energy mix. You have to have an energy mix that meets all of your constraints. So you need all thumbs up. And then more slowly, it's over decades that you got to work on all of those criteria. We also added a total score, which has gotten a lot of positive feedback. And then also a neat addition is the Sankey diagram of their energy mix over the 50-year plan. That all then feeds into their 5-paragraph essay. Probably have already written the first paragraph, and then they evaluate, this is claim, evidence, reasoning. So the evidence is looking at their plan versus a competing plan that ideally is another student's plan, but it might be a plan the teacher is providing as well. And then the reasoning about the best design and limitations of your plan straight out of the evidence statements in the NGSS. Okay. Then there is a graphic organizer for each piece of this, and there is leveled supports. This is also a great day to have adults in the room where students present their explanation. It is powerful to have those adults listening and then, of course, sharing their own professional experiences. That wraps up our short overview. If you want more, check out the full overview.